All right, so we're going to talk about computer vision, which is one of the applications that Dave was talking about. Computer vision has been driving deep learning and machine learning heavily over the past 5 years or so. And in particular, we're going to talk about scaling computer vision both on AI chips and in the cloud. So both of the places that Dave talked about will be pushing the limits of computer vision. So it shouldn't be a surprise to you that computers are opening their eyes now. They're seeing the world in 2D and 3D for the first time, really, over the past 5 years. We've been really poor at computer vision up until the past 5 years, and then ever since it's become possible through the advent of deep learning, we have been pushing the boundaries of compute capability over and over and over again every year. So I would claim that, I would hope that computer vision is one of the most pressing needs that people come to Dave for, to say, hey, look, you should make the TPU faster in this way and that way. We have needs exactly as he mentioned, both in response time and in throughput. For throughput, we are wanting and have a product that will let you visually search through billions of media files as easy as clicking. And this here is a problem of throughput for us because we have to index very large amounts of media and then put them at your disposal in milliseconds. And so I'll be showing you how we do that. And then on top of that, we also have live stream monitoring, which demands a lot of compute, but this time response time, where there are live video feeds being thrown at Matroid. And then all of the video feeds have to be monitored for some particular thing visually, right? So this is another incredibly response time sensitive application that again we saw and we will see for the rest of the talk today. And once again, for training, we'll want to be able to have a large amount of throughput. So the Matroid product also makes you able to have access to training without programming. So these are all little topics that I'm going to go across. So this is very, very high level, 30,000-foot view. So this is all joint work with me and the Matroid team, by the way, of which I'm incredibly proud to be a member. They're all around you wearing teal shirts. This is where we announce our work for the past few months, and it's the kind of thing that we look forward to. And so all of this is certainly not my work. It's teamwork by the Matroid team. I'm going to quickly go over exactly the products that will push computing to its limits. We're going to mount some partnerships, both in AI chips and otherwise, and cloud. And then we have some last announcement to make for you. So how could we apply computer vision? It's sort of a vague question deliberately, but certainly it's not going to be anything different than if you split it up by time. It's certainly not going to be outside of that, right? So we're going to be able to apply computer vision to the past, to the present in real time, and to the future. And each of the three things that I showed you relates exactly that way. So we think we're covering the bases by being able to let you search very large collections of media and then letting you monitor streams as they come, and then letting you build detectors that are sufficiently specialized that they can predict a little bit into the future, like maybe see that a car is about to hit another car or a pedestrian is about to get hit, something like that. Just a little bit of future prediction can be happening if you do proper detector building. So let's actually, if you know me, I'm not going to stay in slides for long. I don't like slides very much. So we're going to go off to the Matroid product soon. But before I do that, I want to sort of remind you what we're going to do. We're going to, on live, search tens of millions of media files in a few hundred milliseconds. And the product revolves around detectors. Recall, I've said this or previous years at ScaleML is detectors are first-class citizens of Matroid. They come into the world being able to see some things. For example, a car or a wrist or maybe a disease in a CT scan or whatever they've been created to detect in the world. They are the first-class citizens of Matroid. Word makes presentations. PowerPoint makes presentations. Word makes documents, and Matroid makes detectors, and you can use them, import them, export them, combine them, and so on. So let's go into the product now and see some of these applications live. And then I'll go into where we're pushing the AI chips and the cloud exactly to do things that were not possible even 2-3 years ago. And now they're available to, well, most of the world. So, so this is, oh no, I need to exit. So this is Matroid.com, and as I mentioned, you can create the site revolves around detectors. You can create new detectors or browse existing detectors. And here I have our existing detectors. So we have thousands of them. I think we have the world's largest body of detectors, and so that you can detect all kinds of things. We have detectors up the wazoo looking for license plates, people, particular people or celebrities, actions, whether someone's fallen down, genders, and so on. Everything you could think of that is a sort of common thing, we should have a detector for it, and if not, we can make one. How do I use the detectors to go through billions of images and video files immediately? So this is the first place that, that we would like to use the throughput of a lot of these AI chips. So what I'm going to show you is going to be on the cloud, and then we will be able to push it to AI chips that are at the edge very, very soon after. So here I have a data set of tens of millions of images, and it's called Open Images. It's a free data set to use by Google, actually, so thank you for releasing the data set. I'm going to be able to run very fast detections on this. I can sort of do it live. I like to do much live, prefer to do live demos because it's sort of less scripted. So if I run this thing live on myself right here, it sort of brings up a lot of people who are at podiums, and you can see the mic. We can maybe focus on the mic there, see what happens. I actually don't know if the mic will get picked up. Well, no, let's tighten it a little bit, see what happens there. No, it gets confused when it's like that. So, yeah, so these guys are all at microphones, and then I have some stuff here that I should be able to detect very quickly. So what I'm holding is obviously a water bottle. If I sort of tighten it around the water bottle, I'll start getting probably things that are related to water bottles, and then, so these are all, this is again, this is why that response time is so important. Each of these images is incredibly expensive to compute neural network operations on, and computationally expensive. And we have to do it. We have to do it so quickly that if we take more than a few milliseconds, it's sort of very unsatisfying, right? You could just move this thing a little bit, and it will redo the calculation for you. So if that's not fast enough, it's not acceptable, right? Last one of these I have, I kind of like this one. It should suddenly decide that I'm wearing shades, and if not, we'll see. So suddenly there's a few people with shades, and maybe if we just focus in on it, we get a lot more of them, right? So these are fun things that we can do. Of course, this is sort of not that weird. There are other places that do this. We're going to be doing, this is the first 2 minutes, 5 minutes of the talk, right? We're going to be going much deeper than this. One of the examples of going much deeper, or a little bit deeper, is being able to do this on video. So we can have maybe a video file of the cars that are driving over the Golden Gate Bridge, and then, so this is our own video player. We built it from scratch. There aren't that many video players or any video players that have been built from the ground up with computer vision in mind. So this is of course one of them. And so you can select particular frames and search with those frames instead. So you can say, well, look, I'm looking for this particular vehicle or vehicles that look like it, and you get trucks that are in open images. So these results are restricted to whatever is in open images. So you may or may not see things that are relevant. And of course, we can maybe open the lens a little bit and look at the whole thing, and you get things like bridges, because this is the Golden Gate Bridge. Maybe if we search for a different car that's a different color there. So here we have a white car. We had a black car before. Let's try the white car and see if we have any difference in the results. Should be more lighter cars. And so we get lighter cars showing up as a result. So this is just the beginning of what's possible now. Search is becoming visual in a very real way. And this is all costing us a lot of compute that we've had to do beforehand in training. Now, this is all, again, maybe not for some of the experts in the room that are sort of computer vision savvy, still, okay, I could do this. Now let's do something that I haven't seen anywhere else before. It's the ability to search with multiple examples. So if I have many pictures of someone or something, and I want to use all of those examples as a query, what do? I can't just put one image in, and I have to select all the bounding boxes. So you can actually query by a whole detector. I'll create a detector later, which aggregates what the query images should be, but I want to run it on this first. So here I have the detector that looks for the past 4 US presidents, and I want to search all of open images for the past 4 US presidents. Open images was collected, I think, 2-3 years ago. And so the presidents that were relevant 2-3 years ago show up much more often. So 3 years ago, the president was Obama. So if we search for Obama and say we want to find all examples of Obama that were showing up in open images, we start getting him. And actually, there's this funny picture where there's someone put in open images this picture. And so on the right is the one that was detected. These two were ignored. And so we then can look for the current president, of course, shows up a lot, right? We can say, well, I want to see where Trump shows up. And then George Bush is a little bit further in the past, right? So he went out of business in 2008, so that was long before open images. So there's way fewer examples of him. You have to sort of bring the slider down to be really uncommon, and then you get that one picture of George Bush that showed up. And Clinton, actually, I don't think he shows up at all. So yeah, you have to really bring down the sensitivity, and you actually get just people who aren't Clinton. If you bring down the sensitivity too much, if you bring down the sensitivity to something that is like an 80%, you don't get anything for Clinton at all. So each of those queries was made by aggregating many pictures of Obama and many pictures of Bush, and we did that actually very rapidly, and I'll show you how that's done in a second. So this is a little bit of a snap, and this is the first time we're actually announcing this feature. So this is collection search, and it has the ability to go through billions of media files in hundreds of milliseconds, and this is exactly why we're so interested in AI chips and the cloud and on premises. So let's move on to the now, right? So we did a little bit of the past, and we'll come back to the past, but let's move on to being able to do things live. And if you notice, I have a bunch of detections right here. Not detections, but notifications. What are these notifications? They're telling me that some of the live streams that I'm monitoring have things that I'm monitoring for happen. So there's a very low response time AI chip monitoring a video stream. And this one of the video streams that we have, oh, I clicked the wrong thing. One of the video streams that we have is in our parking lot, the Matroid office parking lot. This is live Matroid office. So usually you see that someone in the office comes in at around 7 a.m. and we're sort of in the office until 8 p.m. Let's just do that again so that the bar goes away. Good. And this particular stream is being monitored for cars. And so right now at 10 a.m. actually, looks like there was a car in our 10:13 a.m. That was 2 minutes ago. There's a car in our, you see how there's empty cars? Because all the Matroiders are here. Usually it's a row full of cars. If you look back at 10 a.m., these are our cars in there. And I'm detecting specifically cars and nothing else. And this is a really old, boring camera from maybe 20 years ago that our landlady installed. And of course I can sort of look, this is a really bad camera, all these artifacts, and yet people demand that we still do computer vision on these really old, grainy feeds, and we can. And this is sort of monitoring live, right? We'll be able to do a lot more with this than just being able to monitor it live, but it's kind of lame to have to rely on all these old cameras. We have to rely on these really old cameras that give us poor feeds, and we connect them using very standard protocols like RTMP and RTSP. So you can add a new stream through RTMP or RTSP which are standard video streaming protocols. It's the best and most widely adopted standards we could find. How many of you know about RTMP and RTSP? Basically nobody, right? It's kind of surprising that despite the fact that video is now so ubiquitous, a room filled with computer science experts don't know about the most famous protocols for dealing with it. Facebook Live and YouTube Live and all these, they support RTMP and RTSP, but you don't know about it because they're somehow not that popular. And so what we observed is that it's a nuisance to get your stream into Matroid. And so in order to fix that, we built a camera. So this is being announced for the first time today, and everyone is going to get one of these cameras at the Matroid booth for free. So you're very welcome to stop by and get a camera exactly so that you can feed your stream into these AI chips and watch the magic happen, right? So the camera's sort of idiot-proof for me. I'm the idiot here, and the thing just looks like this. It's a very small thing. It's an IP camera, so it wants internet. Or if you want to pump it into Matroid on-prem, which is our on-prem offering, and it doesn't need internet at all, you simply plug it in, and it starts talking to you instead of having to deal with RTMP and RTSP. Once you've plugged it in, it will say something like, welcome, please go to Matroid to get a QR code. So this thing needs Wi-Fi.
Matroid computer vision kit.
Right? It needs Wi-Fi. It's going to ask for Wi-Fi. How do I get it Wi-Fi? All I have to do, it doesn't have a keyboard, right? I can't type on it. So how do I get information into a camera? Right? How do I get it? We're talking about computer vision. We better be able to visually tell it what the Wi-Fi password and details are so that it can connect. So let's do that. Let's very quickly go to the setup page where we put in the Wi-Fi details and the IP address that we want it to connect to. By default, this connects to cloud. If you want to connect it to your own Matroid on-prem, which I'm going to talk about later, you put in that IP address here, and you give it a little QR code, and then it's going to read everything off of that. And so it says QR code found. Connecting to Wi-Fi, this may take a minute. So I'm just going to let it be, and it'll detect a few things about me while I'm doing the talk, and then we'll come back to it, okay? So it says Wi-Fi connected, and hopefully we can see the tick. There we go. So it's connected, and we'll come back to this, okay? Meanwhile, let's go back to the detections here. And this is a video stream from, video streams can come from anywhere. They can come from our camera, they can come from your camera, they can come from TV. TV channels are essentially live video streams for which we have customers as well. So as an example, we have Bloomberg here being monitored for a lot of different things. We have an emotion detector on Bloomberg. We have an objects detector on Bloomberg, and we have a gender detector and that US president's detector that I showed you. These are pumping into AI chips in our cloud. The calendar is much more colorful than before because there are more detectors than before. And so if I look at things like that it's detected, like maybe and by the way, there's a Bloomberg reporter in the audience, so it's kind of funny for her to see this, hopefully. Hi, Dina. And so the detections that we can see, I have it looking for a bunch of things. I have it looking for, in terms of objects, I have it looking for airplanes, birds, boats, and some other stuff. So I haven't seen this detection. Again, this is live. So 9:12 a.m., a couple minutes ago, there was an airplane being detected on Bloomberg, and probably something about the Boeing 737, right? And if we look at the other detections, there's cars, there's a boat, and there's another car. So let's now combine the present and the past. So what if I wanted to see all the times that airplanes showed up in the past on Bloomberg? Now I'm going to hit collection search. So I hit find similar detections. What's going to happen is I'm going to land in the collection search where I'm going to be able to start looking for where are all of the other places all the times on Bloomberg that a similar scene showed up. In this particular case, it seems to be very airplane heavy. So these are all the other times that airplanes showed up on Bloomberg. This is actually fun. Looks like flying cars are a thing. And so now I can play the video surrounding that detection. So when did this happen? This happened, this particular one, happened on December 13th. So we're going quite far back in time. We noticed that there's a Boeing 737, and a little bit further back in time, something else happened. And we can do the thing that we had before, which was just focus on particular areas. So if you focus on the 737, you start only getting 737s. If you start focusing on the guy wearing a tie, probably start getting just guys wearing ties. And if you focus on, maybe, actually I've never done this before, maybe just focus on his little handkerchief there. Do you start getting people with handkerchiefs? I guess there aren't that many people on Bloomberg who have handkerchiefs, so just, there's only so much you can do there. But there are plenty of people with ties, which makes sense. Right, okay. So similarly, I could look for, when did the US presidents show up, and when did all the other things that were being monitored, when did similar things to those show up? So if I'm looking for the US presidents, at 9 a.m., the current president showed up, and I asked for similar detections for the current president on Bloomberg, I get that. This is all happening live, and also so the indexing is happening at the same time as you're getting live notifications. And so you can go back in time and stay in the current. Okay, so let's actually go and see if we got, this is the camera that I just set up, right? It said scaled ML1, right? Scaled ML camera 1, and I have it monitoring for people and for cars. Obviously there are no cars on the stage, but there should be a person on the stage. And oh, wow, flattering, okay. This is happening off of this one streamed to the cloud. At our booth, there are some that stream into just a machine, and so the latency there is even lower. And once I have the detection, I can start seeing what are the things that are happening around it, of course, right? So these are free. You can have 20 of them feeding into a single machine, maybe more depending on the machine. And we have all kinds of partnerships being announced there. So we're sort of touching upon the past, and we touched upon the present, and now let's go and look at what we can do in the future, a little bit into the future. And we do that largely by creating detectors that are particularly smart about what's happening and what they're seeing currently and in the future. So remember that on the front page, you could either create new detectors or browse existing ones. And so far, we've just been using detectors off the shelf. Usually, our customers just use them off the shelf, or our users use them off the shelf, and they go to town. But sometimes you just can't. Like in this case, I want to, say, search for a sedan or a truck. So I'm going to create a detector on the stage for sedan versus truck. And this is maybe useful because I can monitor the Matroid office parking lot to see when our Monday morning food delivery is, because we get so much food delivered to the office that we need to maybe check out for that, right? So we hit create detector, and we start going through the Matroid wizard. So this is a detector creation flow that I'm not going to go into because I've done it once before, and it's sort of self-explanatory. But it's a wizard that will guide you through the process of creating a detector without being a developer. It's going to be a natural imagery classifier, and I'm going to ask for some help with stock images. And I'm going to call this the SML sedan truck detector. Scaled machine learning sedan truck, right? So now we're going to have to quickly curate some training data. So here we have a bunch of sedans and a bunch of trucks. What am I going to be able to do with these trucks? Well, these are examples that we've pre-populated. Actually, these are coming also from some open data sets that I think this one is actually open images as well. So the data is available for free online, and we can use it to tag images of trucks like that. Very simply just say, well, I think this is a truck, right? Building these bounding boxes is such a nuisance, right, that we want you to be able to get some help. We can actually use another detector to help us annotate what's existing in the studio here so that we can rapidly annotate training data. One of the things that software has to deal with is provide training data to feed these training algorithms that essentially do the work, right? And what we're seeing is that having software that does fast, rapid training annotation is key. And so we've really gotten this down to a point where you can even use another detector to help you find cars. So I have a detector that can find cars, right? Cars are trucks. Oh, sorry, trucks are cars. Sedans are cars. So if I have a car detector, I can get the bounding boxes from my car detector. I will run that on all of these images right now, and then it will quickly run for me where the cars are, and I can use that then to my advantage so that I don't have to do lots of bounding boxes. So here, for example, it did the bounding boxes for me. It says there's a car there and a car there, and I don't have to do those bounding boxes. I can just flick through and see where, so here it might have missed some, right? So I can quickly put those in, the ones that it missed. This is a really weird truck, but it's a truck. And so I can go in and basically do this as I please to, and this one's already been detected. So it saves me time annotating stuff. I can, of course, use the video player to also add in some cars. Maybe if I wanted to put in that car off of the Golden Gate bridge, I could select it off the frame selector, upload it, and then say, go in and say that's also a, well, actually I put it for the wrong class. I can say this is a truck right there, and so on, right? So this was an MP4 file that I had locally, and I used the MP4 file exactly for the task of getting more training examples so I can get a higher quality detector, okay? So you can spend a lot of time here, and I'm not going to, but in general, we work hard to make this fast, and there are startups whose entire business is just giving you training data and letting you annotate data. This is just a feature for us, and the ability to use other detectors that you've built to annotate what you have is something that we see. We were the first to bring this out a few years ago, and we've seen it copied. So it's kind of nice to see that, and probably some of the other features that I show will end up in the other products here, but that's okay. That's how this industry works. We understand. So if I train this now, I will get a detector. I'm not going to train it because I'm not going to train it right now because that's not a good use of your time. Instead, I'm going to go to a detector that I had earlier, which is already available. This is a sedan versus truck detector that I trained. I just hit the train button and I land here. So now I should try it. It's sort of obvious that I should try it, right? Before I deploy this thing, I better try it to make sure that it's working. If it's just, otherwise I'm not so sure that it's actually being able to decide if it's looking at a sedan or a truck. Here, it's certainly figured out that it's looking at a sedan. But are you sure that it's really learned anything valuable? Are you sure this detector is working? No, right? You're not sure. You want to make sure that your detector is working well enough before you deploy it to do all kinds of really mission-critical things. So what you do is you ask the detector, why do you think this is a sedan? And you do that by asking for a sensitivity map that we're generating here. It's a little bit of a compute-intensive operation, yet another one of those operations. We're going to ask for the saliency map for this thing, where every single pixel will be highlighted with how important it was for the detection to come out as sedan. And that means we'll have an understanding of whether the detector learned about the true features of the car, or whether it learned that, oh, maybe every time there's some trees in the background it's a sedan, because that's how the training data was set up, right? So here we have the original image, and then we have the saliency map overlaid on top of it. And so now you can see that it's perfectly focused on the parts of the car that matter. It's focused on the car. It's focused on the parts of the car that help you distinguish between cars and trucks. And this is now one step of being convinced that this thing is actually detecting the right things. And saliency maps have actually been largely a body of research from now on, and I'm pretty sure this is the first commercial product to include saliency maps in any way at all. So this is yet another place where we take, as soon as research we believe is useful to you, we'll put it out there. And as soon as we think AI chips are pushing the boundaries, we'll have you be able to use it. This is exactly the kind of thing you need to be able to convince yourself your detector is working. The other thing you want to do is to get a PCA embedding of how the detector sees the training examples, right? So these are the training examples colored by their true label from the studio. So the blue ones are the sedans, and the orange ones are the trucks. And this is and their position in 3D space is what a detector thinks it's seeing. So if we see a great separation of the colors, then we know that the detector has learned how to separate trucks from sedans. And indeed, it has for the large part, except for these few that are close to each other. And if we zoom in there to see what's going on, we see these really weird trucks that kind of look like an older truck maybe, and it's confused by that. So if we think that this is an important truck to us that we have to get right, we can either add more training examples of it, or if we think we're never going to see it, we remove it altogether. I have, we do this before. Like I got a detector looking for airliners versus fighter aircraft, and it was confused with the space shuttle because it wasn't quite sure whether the space shuttle was an airliner or a fighter aircraft. And probably I'm not going to see that on my parking lot, right? So I have a sedan versus truck detector. What can I do with it? Of course, I can go back and search very large collections of media in rapid time. I can also monitor a stream. So if I wanted to monitor a stream, say the Matroid office parking lot for trucks, I could say, well, look, I want to monitor this stream for trucks, and I want a detection whenever trucks show up with 49% confidence. And I want to start now, and I want to finish never. And then I hit submit. And once I hit submit, I land in that in the same pattern that I showed you, the calendar that I showed you. I can also enable a focus area and say, well, look, I only want detections for the truck when the truck shows up in our driveway here, not when the detections show up, say, because the truck is parked. If the truck parks, I'll just start getting notifications over and over again because there's a truck, there's a truck, there's a truck, there's a truck. I don't want that, right? I just want trucks when the truck's here. So you can do that and exactly bring down the notification count to the relevant notifications. And once you hit submit, as I said, you'll land in a sort of a calendar like this that will let you be able to check things out. So let's go one time back to the detector again. So this was in the wizard as I was going through, what I did was I created a classifier. I specifically said I want to create a classifier, and a classifier classifies the whole image. That has benefits because sometimes you want to classify the whole image. It's a whole image kind of detector. And sometimes you want to say, well, no, actually, something's happening in this particular area. You want to give a bounding box. So in those cases, what do? You can either train from scratch something that has bounding boxes and paints bounding boxes. I'm not going to do that because just follow the wizard. It will tell you, do you want bounding boxes? And you say yes. And it will ask you for bounding boxes. So this is sort of in there. But sometimes you already have a classifier, and then you want to combine it with another detector that draws bounding boxes. For example, here I have the ability to tell between sedans and trucks, but I can't draw bounding boxes. The bounding boxes, though, if I had a car bounding box detector, then I could use that. So I could combine the two detectors together, combine the car detector and the sedan versus truck detector to create a localizer. So once I say that, look, combine these two detectors together, I get a new detector. So this is sedan with truck with car localization. This is a new detector. It has all the features that I showed you earlier, but now it draws bounding boxes. So if I run a bunch of files on it, it should be able to say, well, look, there's the whole image isn't just something. Now I have a particular truck here, or I have a truck and a truck and a truck and a truck, and lots of sedans, right? These are useful for traffic counting, say. We have a customer that just, one of the nice things about vision is that it's the ultimate sensor. It's the ultimate way of sensing things about the world as long as it's possible to sense it visually. So there are so many roads have been dug up just so that you can get traffic counting going. Like under the roads, there are giant car detectors that detect the metal in the car. And they cost hundreds of thousands of dollars to install. And a little dinky camera like this now can do it for a fraction of the cost. And so all across Italy now, there are Matroid detectors looking for how much is their traffic on this highway. And we did that at an absolute fraction of the cost to doing it with the traditional way. And this is just taking over in so many places. It is the ultimate sensor in that regard, and this is why I'm so excited about it. And that's why I'm essentially all in on computer vision, and I'm loving every bit of it. And every day it's like a reaffirmation of the power of it. So, we have now this detector. It localizes great. Okay. What if I'm a slightly more advanced person? Everything I've shown you has been point and click, drag and drop. A lot of the people in this room are advanced enough to go into the nitty gritty of a neural network and attack it as they want. And for that, we have, of course, an API. So everything I showed you is available via an API. So you can build detectors, and after you've deployed them, you can get notifications programmatically. You can do everything I showed you with simple APIs that someone maybe who did a high school could do. So someone who high school programming class could do, right? And this is, I'm not going to go through this because this is sort of self-explanatory as well. What I want to go through is maybe go back to that detector that we had. Go back to the detector and look for some more advanced tooling here. So you saw the visualization of the PCA. What if we wanted more? Well, we can dig in and go into Matroid board, which is built on top of TensorBoard, and see what a real deep learning scientist would want to see, which is things like what is the accuracy on the trucks, what is the accuracy on the detector, on the sedans. So if you have access to the architecture, what is the architecture that the thing is using? Maybe you want a fancier PCA projection with all of the nice bells and whistles that you've come to expect in a research environment, and this is essentially a much more powerful version of what I showed in the actual product. This is for a deep learning engineer to plot in various ways. So here you can go in and really get your hands on the model and what's going on. And you see how it's separated from the main product because it's another level of skill that is needed, and that's very much deliberate. Another way, if you have the skills to do it, to use Matroid, if you say have a model that is ready to go, you can import it to then be, and you can export it afterwards too. There's nothing we try and essentially have zero lock-in. We really want to win your actual usage via actual usage, like being useful. And so if you have a model that you think you could leverage some of the tools that I showed you, like stream monitoring and just like all the plumbing around the camera and things like this, if you have a model that you just want to use, you can do that. You can import it. We support TensorFlow saved models. We will be supporting PyTorch. Right now we're focused on TensorFlow. And we have the ability to just upload a TensorFlow protocol buffer. That is, this .matroid file is just a zip file that has a protocol buffer in it and some configuration parameters, so you can just rename it to a .zip file and take a look on the insides. I'm on a really slow LTE connection, so apologies for this. So this is only a 14 megabyte model, so the fact that upload is going so slow just tells you only about how fast my LTE connection is. And it's just sort of here, so I'm going to put it up a little bit higher. Oh, yeah, I feel like maybe it's sped up a little bit. So while that's happening, we are writing an entire book. Well, I wrote an entire book on TensorFlow. It is available at the booth. It does seem to be one of those interfaces that is a very good candidate to be the language between the AI chips that we're seeing at this conference and higher level applications that are coming into the scene. Like Matroids. It seems to be like a very good way, a good abstraction layer that has the ability to both go into C++ and into Python based on how nitty-gritty you want to be. And so we feel that that's been quite successful. One of the nice things about having the ability to upload these models is that we probably see more neural network architectures than anyone else does. All of the AI chips here probably are going to benchmark on ResNet 50 or some combination thereof. We probably have thousands of different architectures that we care to be optimized, and we would love for some of these AI chips to be moving off of ResNet 50 soon. And so please do that. This is, Dave said, we love hearing startups and companies that want more compute. We want more compute, but for all kinds of different architectures. And if you want help seeing which architectures we want help with, we'd love to work with you on that. So this was a gender detector. I uploaded it. It's sort of a trivial thing, right? It's easy to do gender via face these days. And so I uploaded accidentally an emotion detector. I thought I'd clicked on my gender detector. I uploaded an emotion detector. And the emotion detector is a little bit bigger. It's around 18 megabytes, 80. No wonder. So it's sort of like I have a neutral face here, and I'm kind of happy. Maybe if I go, ha, now I'm happy, right? That's okay. So then you go, monitor, like, what is the average sentiment on Bloomberg, right? Actually, we did that. We monitored what is the sentiment on Bloomberg, but we also monitored what is, like, the gender distribution on Bloomberg. Some interesting things there. I forgot to show that. I kind of want to show that. So we can do, on the real time, we do analytics sort of immediately. I'm trying to find it. Where did I put it? It's under streams, and then one of my streams that I'm monitoring, and then under Bloomberg US, right? So if I go to the analytics on Bloomberg, I get the analytics for the gender detector, and get the reports for Bloomberg US gender. This is gender, actually I want the other one. Ooh, I'm in the, I closed my tab, shouldn't have done that. Streams, and monitoring, Bloomberg, analytics, gender, and gender. Okay. So here I have all kinds of analytics on what is the number of detections for male versus female on Bloomberg. And the blue is male, the blue is female, sorry, and the orange is male. And so we have roughly 2-to-1 correspondence between male and female. And this is a by week basis. This is total detections by day of the week and by hour of the day. It's consistently 2-to-1. So it's sort of a business channel. And you can see sometimes during the evenings it's more close to parity. So I think that's when, like Emily Chang, the primetime person, comes up, and so she sort of makes it a little bit more equal in terms of representation there. And so these analytics are also available. You can just export them as well. As soon as you have a monitoring going, like if you want to get what is the distribution of, I don't know, trucks versus sedans in a parking lot, or how many cars are there in the parking lot, you can get that with these analytics very trivially. And if you want to use that analytics anywhere else, you export them. We will not lock you in. Okay, so let's go back to the slides and sort of wrap things up. So what did we see? We saw a studio for making and using detectors. So this allows us to annotate rapidly and go to town. We saw, and so this is a feature for us. It's a small feature that we're proud of, and there are entire companies that do this, and I hope they continue doing it. So we also have an ever-growing detector library, so hopefully you won't even have to make a detector. And if you have trouble making a detector, we'll help you, or you'll build it with the wizard. And there are all these things that I didn't really have time to go into. Of course, we saw the video player. We didn't see feedback. You can get feedback everywhere. There's an API that I didn't go into. There's work sharing with privacy. By default, your stuff is private. When you make a detector, that's yours. We do not have your detector available to everyone when you make a detector. It is your detector. Unless you hit the share button, it is your detector. I have to be very explicit with that so that you don't think that, oh, if you make a detector, you're going to steal it and take it elsewhere. No. You make a detector, it's your detector unless you hit the share button, and then we get to use it. And you can deploy with real-time analytics like I showed and go back into very large, for very large times. And so for each of these, I claim that for collection search, no one can do the ability to search very large collections using multiple images, as far as I can tell, with just a point and click. No one can monitor a video stream with just point and click. I haven't seen that. Custom detectors, to the point that we've done it to the full stack of annotate, train. The training, actually, I didn't talk about that at all. We have a whole set of folks who work on training dedicated at Matroid. They are AutoML and transfer learning experts who will figure out what is the best way for your training to happen. And training usually happens within a few hours, sometimes minutes, depending on how much transfer learning happens versus how much AutoML happens. And all of that happens in the background so that you needn't worry about it. This is exactly the kind of thing that we're very good at. I've been working on training things for my entire career, so that's one of our core competencies. So we've met, Alan Kay, another Turing Award winner, has a very famous saying, make simple things simple and complex things possible. And that's the driving design mantra that we've had when building Matroid. You saw the very simplest things were very, very simple. You could just point and click, get to monitoring. And then if you are more advanced, you can, of course, go in and use TensorFlow and go in and do more optimized things. But in general, what happens is we see the deployment cycle go from months, maybe even a year, to deploy computer vision in an application to hours. And this is exactly what software and technology is supposed to do, is save people's time. There are a lot of folks in this room who are perfectly good at computer vision, right? A lot of you are interested in AI chips because you're good at computer vision or deep learning. And what we'd like to do is we'll give you tools to make things go faster. This is these are one of them. And there are a lot of tools that we have that make complex things possible that I didn't have time to go into. Like you can combine detectors in all kinds of weird ways that I haven't shown. There's a sliding detector for very large images like satellite imagery or stadium imagery or things like that. You can improve on an existing detector by redoing it. Didn't have time for that. You can auto-label with existing. I showed that briefly. You can import. You have visualizations and all kinds of ways to interrogate the models. These are all for the complex folks. You can deploy with Matroid.com, as I showed, and on-prem. So on-prem is one of our most, this is where a lot of customers use us the most. So what happens is they use the cloud to train. They use the cloud to see what's going on, how can this be beneficial to them, and then they deploy with on-prem. And we have several on-prem partnerships, which I'm very proud to announce today. Before I do that, I want to tell you what is on-prem? Well, it's a workstation that can have any AI chip inside it. So it can have all the fancy chips that you know and love. It can be connected with many Matroid cameras or whatever cameras you would like with RTSP and RTMP. And so a single workstation can handle, on average, 20 video streams. A single workstation, a few $1,000s, you can monitor 20 video streams with it. And that's like 20 roads that didn't have to be dug up, right? For $2,000 or $3,000. I guess this is technology helping you do things rapidly. And it's completely disconnected from the internet. There's no internet required, so that if you have some qualms about privacy, like there's some HIPAA regulations or something with health data, don't have to be connected to the internet. Can be completely firewalled, can't have any AI chip inside it. And today I'm announcing two partnerships, one with HP and one with Dell. We are certifying a line of HP and Dell machines in order to sort of say, look, these are the machines that will run Matroid to a certain number of video streams, and these machines are out there in the booths. They're available for you to play with, to look at, and very much the HP and Dell guys are awesome people who are here helping us get this technology in the hands of more folks. So thank you to Jared, Damon, David from Dell for these. Jared from HP and David from Dell. We have a cloud partnership to announce today, which is we are becoming the Oracle Cloud Vision provider. So if you are wanting computer vision and you're somehow tied into Oracle's ecosystem, we're by default the place you would go to. Already, it's available in a point-and-click manner off of the Oracle Cloud Platform. You can now monitor video streams, and then the detections and whatever else you want in terms of notifications are automatically populated in the Oracle Cloud. And that has been a really interesting partnership with us because they have such a larger sales force than us. We're a fairly small startup. They're a giant company. And so our reach has been magnified several-fold by the ability to have access to the cloud platform. And if you are on any of the other cloud platforms, we're happy to work with you as well. It's not at all exclusive. We are running on all of the major cloud platforms, including GCP, Azure, and AWS. And so one more thing is that everyone is going to get a free Matroid camera. These cameras, this is exactly what I said with regard to it's easy now to pump into these AI chips and watch them go even as a regular programming person. And so, as I mentioned, we wrote a whole book on TensorFlow. It does seem to be a very strong interface for AI chips and software that is building on top of them. So I recommend that you at least take a look at it. We have all kinds of features that support the open source community, including importing saved models, and in general, it makes for a very thriving sharing community. And so we have our Series A done. We were profitable last year. We're incredibly excited to be hiring very aggressively. So if any of you are interested in computer vision, in being able to push the cutting edge of computer science, being able to push the cutting edge of machine learning, we would love to work with you. We're looking for folks in video and deep learning, distributed systems, JavaScript, and automation, and we already have experts in all of these that would love to work with you. Please take a look at matroid.com/careers and email us at careers@matroid.com. So that's all I have. I really appreciate it. Almost everything I have. So there's one thing that's very near and dear to my heart, and that is healthcare. So with AI, there's a lot of things that that we can do now that we couldn't do before, just in the past 5 years with computer vision getting to the state that it's at. So there's a quick story here that I promise you is relevant. So back in April 2017, a guy by the name of Robert Chang emailed me and said, hey, it actually was a LinkedIn invite, said, hey, I'm a professor on the Stanford Ophthalmology Department, and I'd like to invite you to Hong Kong to come give a talk about computer vision and stuff. So, okay, sure, I'll come to Stanford to come give a talk. I'll come to Hong Kong to come give a talk. So I went there in July 2017, gave a talk, got a lot of people excited about computer vision, and they're very much excited about computer vision as well. Ophthalmology is the study of eye diseases for those who aren't comfortable. And so we had dinner in Hong Kong, and we were talking, and he says, yeah, well, I'm a professor at Stanford. I see a lot of patients every day, yeah, I'm in the Stanford hospital. And I said, oh, I go to the Stanford hospital to get my eyes checked once in a while. And he says, well, I'm a glaucoma expert. I check people for glaucoma. So he's a world glaucoma expert. He's dedicated almost his entire career, more than a decade, probably more, probably 15, 20 years, just on glaucoma. And I said, oh, I have to get checked for glaucoma occasionally. I have perfectly healthy eyes, thank God. But every 3 years, I have to have a scan just to check. And it turns out he's my doctor. So this guy that I'm meeting in Hong Kong, I saw him in March of 2013, long before he invited me to Hong Kong. And I couldn't see him because I didn't have my contact lenses on at the time, so I had no idea what the guy looks like. He didn't see, I mean, he sees 200-300 patients a day. It'd be like me trying to remember one of my students. This is harder than it's hard. So we realized in Hong Kong that our relationship has gone back further than we thought, and so we started an even deeper relationship. So we started working together on using computer vision to detect glaucoma in OCT scans, and using Matroid and other things. So what is an OCT scan? It's an incredible thing. Modern medicine is absolutely fascinating. As a computer scientist, I'm in awe of what they can do. So they shoot lasers in the back of your eye and essentially get a biopsy of the entire eye. So imagine if you could take the eyeball out, slice it up, and look at some of the cells at the back of the eye under a microscope. You can do that without taking the eye or destroying it or harming it in any way by shooting lasers into it. So you shoot lasers into the eye, and then, it's a very low power laser. It's going to bounce off of stuff. And based on how far it goes and the properties of the thing that bounces off, we can tell what the properties of the cells that it bounced off of are. And you can go all the way back to the back of the eye, down to the nerve, and you do that a lot. You repeat it, and you get a whole 3D image of the eye. It's as though you've essentially cut up the eye, and you've looked at what's going on inside it. And then you cut that up in 2D chunks. It's a 3D thing. You cut it up in 2D chunks, and a doctor like Robert looks at it, and he, using his human eyes, eyeballs it, and then decides whether you have glaucoma or not, or whether you're a suspect for glaucoma or not. And so, and OCTs are inherently three-dimensional. And back in 2016, Matroid was the leader in the Princeton ModelNet Challenge, which is exactly computer vision on 3D objects. So we're very good at this. I figured this is exactly the kind of challenge that we should do. So we gathered data from Stanford and from Hong Kong hospitals. I'm in the data set because my scan was, we gathered data from the past as well, and I'm one of my, I don't know which one I am, but one of my eyes is in this data being trained. We have hundreds of patients, and this is the task. The patient comes in, you perform 5 tests, one of which is OCT, and from there you can figure out if they don't have glaucoma, or they have glaucoma, or they need to be monitored. And so we built a classifier to decide whether they have glaucoma or they have, whether they're healthy or they have glaucoma. And our current models actually distinguish between true normals and true glaucoma with an AUC of 0.95, better than Robert. So this is incredibly exciting, so that we can actually push the boundaries of medicine with computer vision. And so then, of course, we have to convince ourselves that these things are not just, learning off of the noise in the OCTs. How do we do that? We use the saliency maps, right? So we plot the saliency maps. The blue here is the actual scan, and the red is where the focus on and the most important parts of the detections are. So then that does correspond to where Robert looks at for detecting signs of glaucoma. But what we're seeing now is, in addition to the places that Robert looks, we're also seeing places that the model is focusing on that current doctors are not focusing on. And Robert is a world expert in glaucoma. He runs a whole conference like this just on glaucoma, just one disease, all just on world experts on it. So they see the activations in areas that we haven't seen before, and it's incredibly exciting that we're actually going to be pushing the boundaries of medicine as to diagnosing glaucoma to see where this model is being able to perform better than human, and maybe performing some experiments, and then hopefully the goal is to put this as a second opinion in the Stanford Hospital to help Robert, and then hopefully the rest of the world. So this is all going to be published. The results on this are going to be in a paper. This is not proprietary anything. This is research that we do, one, to showcase Matroid, and two, to help the world. So this is very much a labor of love. So we're excited by using computer vision and AI to help and to heal people. Some of our competitors use computer vision and AI to build weapons, to kill people. We don't. We'd much rather help and heal people and actually make a difference there. So I hope I've convinced you that computer vision is at least at the forefront of AI. It's really, really pushing the boundaries, and I hope that I've made a good case that Matroid is at the forefront of computer vision. This is joint work with a lot of people at Matroid. I really have to, this is all teamwork. None of this is just my work. It's all at least 3, 4, 5, 10, 20, 30 people. And again, we are hiring. If this is the kind of thing that tugs at your heart, we would love to sort of sit to work with you. Thank you. Appreciate it. I went a little bit over time. I have time for 2 questions. I didn't go over time, but I didn't leave enough time for questions, really.
Hello.
Hey.
Yeah. This is Hongbo from the startup Pentium. So I'm interested in your application is the OCT application. So in your slides, you mentioned that your OCT application get the accuracy is the point.
AUC. Not accuracy, AUC.
Yeah, AUC, but OCT's application. So the 0.95. So I'm interested in how many patients are you using for your training, and all of the patients' data, did you connect it from just one machine or the multiple different machines? How many machines are you connected data?
So we have, I believe, on the order of 400 or 500 patients. I don't remember the exact number, so this will all be on the blog, but something like around 400 or 500 patients. This is all very sort of recently come together, so that's why it's a little, I don't have as many details on that. So 400 or 500 patients, at least 2 very different bodies of eyeballs, Hong Kong eyeballs and Stanford eyeballs. And so we actually did something extreme where we also did we trained on the Stanford data using the Stanford machine, and then evaluated it on the Hong Kong data from the Hong Kong machine, and the results didn't drop dramatically. So this is very much it's learning something, and we're convinced that it's learning something valuable because of exactly that it focuses on the parts that Robert focuses on. And it's early days. We'll be ramping that up, that AUC. As far as it will go, we'll be really investigating where are the parts of the model that the thing is detecting that humans don't focus on, and really making sure that we do a good job before we put any actual eyeballs in experiment, I guess.
Okay, thank you.
Thank you.
Hi.
Hey.
Interesting presentation, thank you.
Thanks for coming.
Yeah, I have a question regarding the train model. Once you train model using your web-based platform, can I export it and play with it in vanilla TensorFlow? For example, I want to chop last layer and 2 more layers and do custom things on top of.
So if you built it, yes. If the model is somehow building off of a model that someone else has done, then no. So the privacy does matter. Yeah. People do value their architectures quite a lot. So if it's an architecture that you built, then yes. you can do everything that you can export it and do everything that you just said, which is export it, chop off whatever models, labors you want, and do whatever else you want. Yes.
And-
Yeah. But in general, we have to
Yeah.
respect people's architectures.
Sure, thank you. So currently, I assume you are using TensorFlow pre 2.0 version, right?
Yes, because TensorFlow 2.0 isn't I don't believe it's past sort of, it hasn't passed
It got
GA,
GA last
yeah.
week, I believe.
Well, okay, so yeah, it's a little too soon for we were busy preparing for this conference.
Yeah,
But
sure.
yeah, very likely we will be importing that. We already support saved models, which is one of the things that is big in 2.0. And so there's nothing stopping you from, say, working in TensorFlow 2.0 and then importing a model. It'll likely work. Although, yes, we will be upgrading to 2.0 to get all the benefits.
Yeah, sure. Thanks. It sounds very interesting. And reason for asking this question was whether this platform is immediately usable for researchers as well, not just the end users who want to deploy their models in production. So
Yes, it is, yeah.
Okay, thank you very much.
Thank you. So we'll be at the Matroid booth all day. And tomorrow we'll have all day. So let's clear the stage for Dimitro, who's going to tell us about AI applications at Facebook.